So that's sort of camber recovery. Yeah, so that's basically it. And if you on YouTube, there's some videos you can see of camber recovery, and you can watch the actual motion and things like that. I should have perhaps got this rig out and shown you that as well. So you can still see that. Okay, so roll centre. Okay, so the roll centre is the point, the instantaneous centre rotation of the body with respect to the ground. Okay? So as the vehicle is travelling, okay, the body will roll with respect to an axis, okay, which is the roll centre, the line that connects the roll centre at the front and the roll centre at the rear. Okay? The roll centre for an axle is the centre of rotation. Okay, so it's not the centre of gravity; it's a different point. Okay? The roll centre is specific to the axle, and the line connecting the front roll centre with the rear roll centre is the roll axis. And it's around this line that the body rolls. So if I go back to the picture in chapter 2, there was let's go back to the beginning. Okay, so if you remember, in chapter 2, we had this diagram. Okay. So you can see that RC is the roll centre. This is the front, this is the back. Okay, so you've got your roll centre at the front, the roll centre at the back. The line connecting the two is the roll axis. And often these heights of the roll centre, that's quite a significant impact. I'll talk about in a second. You can see that often the front roll centre will be lower than the rear roll centre, and that gives the roll axis a bit of break. That has an impact on the roll angle and all that sort of stuff. So you've got the centre of gravity here in this picture, okay, which is this point here. So as the vehicle rolls, it's the centre of gravity that line, and there's an angle theta there, which is your roll. Yeah. So how do we find the roll centre? Okay, well clearly if you've just got a simple swing arm, okay, connected to the centre of the car, the roll centre will be around that swing arm that's pointed. But often that's not suitable. So with a double wishbone suspension setup, what you've got to work out the roll centre, you've got a couple of steps to go through. Okay? So if you project the lines of the roll centre either in or this way or this way, they're converging, okay, then they will intersect at some point. Okay? Where that intersection is, that's known as the centre. And then basically, the motion of this wheel and the chassis, okay, with this setup, is effectively the same as if the ship was over there. Okay, so here's your vehicle. The motion of this wheel, okay, with respect to the chassis, okay, is in this situation, it's the same as you have a swing arm that long, okay? Basically, so like I said, this wheel is going to move up and down. It will camber slowly as it moves up and down, and it's going to camber effectively as that picture there. Now, clearly, what's slightly different is that as this moves, this rolls this into because those wishbones are going to change in terms of orientation. So there is the centre will change, but at that point in time, it's moving like this. That's pretty good. Front view. I can't remember what it's called in the book. Front view or something. Front view. VSA. So, like I said, the top and bottom wishbones will pivot around their mounting points. The movement of the wheel is in a circular path, okay? with the centre at the projected intersection of the wishbones, okay? Which is known as the incident centre. Like I said, if your wishbones are converging or diverging, then that incident can be outside of the, inside inboard of the wheels, or it could be outside of the wheels. If you've got wishbones that are diverging or converging in the opposite direction, then that incident centre could be, and like I said, effectively what you've got is the motion of the wheels that's got this effective swing arm motion. Okay? And that swing arm length, or could be considered as a swing arm of that length, L FESA, front view swing arm. And as I mentioned, it will move about depending on design and deflection. Okay, so clearly, but at that point in time where that wheel is in that position, the motion either side of that will be effectively the swing arm with that length. Now, to work out the roll centre for double wishbone suspension, what you do is you take that centre. So on this side, okay, you've got these upper and left wishbones. They project out to make it into the centre. So that into the centre is for the left-hand wheel. Okay. So then we'll ignore the right-hand wheel. Okay. And what you do is you then draw a line between the instant centre, okay, and the contact of the wheel. Okay, so you do that for the left wheel. For the right wheel, you've got these slight widths in that instant centre. Again, a line between the instant centre and the centre patch of the contact of the wheel. Where those cross, that's your roll centre. Now, if you've got parallel wishbones, clearly they're not going to intersect with any point. Okay? If they do, you've got infinitely long wishbone infinitely far away the length of that. Okay, so obviously if this is really, really far away, drawing the line between something that's really far away and the contact patch of the wheel, you're going to end up with a line that's basically one way to get the roll centre off the ground is to have the your wishbones parallel. So certainly the point of intersection is not existent in a sense. Okay? So it's infinitely far away effectively. It's the intercept at this point your roll centre. So to clarify, to find the roll centre, you project the line from the centre of the tyre contact patch through its front view instant centres, okay? So there's a line between the contact patch and the instant centre. Project it through, you repeat the process for the other side, okay? And then where they intersect is the roll centre of the sprung mass relative to the ground, okay? That gives you the roll centre for a double wishbone suspension system. Now, the roll centre height is quite a significant impact on the vehicle, okay? As we said, the roll centre establishes the force coupling between the sprung mass and the unsprung mass of the vehicle, okay? Centripetal forces, or centrifugal forces, act horizontally through the centre of mass, and clearly there's a distance between the roll centre and the centre of mass. If we go back to that picture, chapter 2, you've got that distance A. If there's a force being applied to the centre of mass, and this is the roll axis, clearly there's a force can be applied. It's going to rotate the body around that roll axis. So that force, big F here, actual force being generated is going to obviously act upon the centre of mass of the body, because the sprung mass of the vehicle is centred around that centre of mass. If you apply a force, it's going to rotate around that line. Distance A. And that distance A depends on the height of the roll centre at the front and the rear. So the vertical distance between the centre of mass and the roll centre the vertical distance between, basically it's a torque, a couple, okay? So the centre of that vertical distance times by the natural force being generated on the centre of mass will give you a torque in Newton meters, a roll couple. Okay. If the centre of gravity is defined as h, so the height of the centre of gravity is defined as h, and the front and rear roll centres are hf and hr, respectively, then the distances between the centre of mass and the roll centres at the front and back are af and ar. Okay, so if I go back to that picture, chapter 2, so you've got hf and hr. So here, hf, here's hr, so that's the height of the centre of roll centres, and clearly AF, which is the distance between this point and the height of the centre of gravity, and knowing what those things are, and the length of the wheel load, you can actually work out what 8 is. Okay, so these are the points worth noting. So about roll centre height. If it's coincident with the centre of the sprung mass, okay, clearly there's no roll couple being generated because there's no distance between the two. Okay, so the roll movement is minimal. Okay, but there's an issue with that. Okay, if you see, you can take that to extreme and actually position the roll centre above the centre of the sprung mass, in which case the chassis will roll in the opposite direction. Okay, so it basically acts like a sort of pendulum. Okay, so it rolls the one way. It has no effect on weight transfer, and in fact it's possibly detrimental because you've got more weight over the outside wheels than you would possibly want. Okay, and there's also an issue with the high roll centres.
You turn left.
Sorry?
Car. You turn left. The car would turn left.
The car would roll like in the same direction as the motorcycle, but they would roll out. Yeah, you'd end up with this it's effectively you've got a pendulum, an effective pendulum. Because the roll centre is above the ground, the thing is going to roll out. But yeah, but the actual direction would be pointed towards it. Like I said, it's not ideal in terms of balance of the vehicle going across the axle. Ideally, what you want is a roll centre. Okay, that will give you a bigger magnitude of roll couple, increase, okay, but obviously this is often desirable. Okay. And if you've got a high roll centre, which is the case if your roll centres align with the centre of mass, or if it's above the centre of mass, you get lower roll couple, or a decrease in roll movement, okay, but those are outweighed by, you get a high lateral wheel scrub, okay, so the wheel wants you to move sideways, and you also get this phenomenon known as jacking, okay, which basically is as you corner, you'll end up with the wheel because of this lateral wheel scrub. You end up with the wheel pushing the chassis up. Okay, so you end up with that can often lead to massive positive camber on the wheels. Okay, so you want to avoid jacking. So, which is one of the situations with short swing arms, you end up with a very high roll centre. And so if you look at a car that's got the swing arm type especially set up, old-fashioned cars often just had the swing arms that went out, okay, short swing arms, and they, obviously what you get with that is a very high roll centre, and like I said, these are jacking. Now, a long time ago, way before my time, let alone your time, there was a vehicle in America called the Chevrolet Corvair, okay, which was quite an innovative vehicle back in the 60s, 50s, I think. Let's see what I can find it on the internet. Let's go there. Corvair. There it is. 1959 came out. Okay, there it is. Nice picture. Chevrolet Corvair. Unusually, it was rear engine, like a Beetle. Okay. The other unusual thing is it had the swing arm rear suspension is short swing arm, so it had a very high volt center at the back. And there was a bit of a scandal when it came out. A chap called Ralph Nader, who's a let's see if it's mentioned down here. Handling issues, yes, oh yeah. Rear engine and the swing axle design similar to that of the Renault Dauphine and Volkswagen Beetle. A design which eliminates universal joints, okay. So there's a picture of the swing arm suspension, okay. So you can see it's got very short swing arms. Okay. The issue is that you end up with a jacking situation where the scrub will stop the wheels get back out of the corner. You end up with a situation where you've got adverse camber or positive camber on both sides. So it's such a situation. This is obviously pretty bad in terms of grip. It's a corner. Yes.
After the bumps, this happens.
You can, yeah.
The rebound.
Bumps can induce that. That's right.
After certain.
Because obviously, if you look at what's happening with this wheel, okay, obviously, as if you've got a short swing arm, as that swing arm moves, this point moves out naturally. Which is the scrub. And what can happen is actually, as you go down the corners and the suspension moves, you end up with a point which these wheels will naturally come in, jacking the car up, okay, and causing that to be. And this chap, Ralph Nader, who was actually a presidential candidate at one point, wrote a book called Unsafe at Any Speed. And partly that was to do with this setup, okay. So, yeah, design can allow the rear tyres to undergo large camber angle changes during fast crawling due to side G forces causing rebound camber, so that's the jacking, decreasing the tread contact patch with the road surface, leading to a loss of rear wheel grip and oversteer. Again, that would be unstable situation, okay, unsuitable condition where the driver can lose control and spin, okay. Problems most severe in combinations having the engine and swing axle in the same end of the car, okay, because it was rear engined. And this Corvair, and the Corvair is no exception. Okay. The rebound camber is worse because of the greater inertial mass over the rear wheels. With this combination, the higher centre of gravity during rebound causes additional problems. Okay, and if you've obviously got in the state car, station wagon, you've got even more weight over the back. And if you decelerate in the corner, obviously that also lifting weight off of the rear, you end up with this situation. Yeah, pretty bad. Okay, so there's a couple of design options to ameliorate swing axle handling. Fit an anti-roll bar. Okay, and then the tyre pressure differentials with the Renault Dauphine and the Beetle. Corvair engineers relied on a cost-free tyre pressure differential to eliminate oversteer characteristics. Okay, where you have different front and rear tyre pressures. But like I said, it eventually became such an issue that there was loads of litigation, it being the States, okay, and they had to do some big changes for the Mark II Corvair. So there we go. A bit of anecdotal evidence of why high roll centres are bad. Okay. You end up with, like I said, so there's some pictures. So you can see as the instant centre is high, as the wheel moves through its motion, the scrub distance is large. Okay, and like I said, the reason why you get this jacking is if you look at the forces coming through, you've got your centre of gravity up here, and so you apply a lateral force, obviously that needs to be generated by the tyre. Okay, but obviously this force, it goes through the instant centre. Okay, now if the instant centre is high, okay, you end up with a situation where there's a large vertical component to that force, which is the body weight, which is the instant centre. Okay, so this is with short swing arms, okay? With the simple swing arms, you can see this is how to calculate the roll centre. So, obviously, the instant centre for the roll for the swing arm will be the mounting point of the swing arm. Okay, so you got this point here, Clearly, a line between the centre point and the instant centre will give you a line that goes up here. Likewise, it's very high roll centre height. That's just underworld. Now, for the strop based system, which is what you looked it up, okay, the way to work out the roll centre, like I said, you project the lower wishbone as you did before with the double wishbone. But this time, instead of the upper wishbone being also projected out, okay, you take the top of the strop where the strop's mounted and you draw a line that's perpendicular to the strop direction. Okay, so it's perpendicular, so essentially, they will be correct, essentially here. And then obviously, again, it's the centre, it's the centre of the wheel, okay, where they cross with the wheel centre. Clearly, if your wishbone is mounted more horizontally, okay, then the instant centre will be further away, and the roll centre will be lower down. Further away, the line connecting this point and this point is going to get lower in this angle, basically, you get lower and lower, which will reduce that. The semi-trailing arm, as we talked about last 2 weeks ago, wasn't it? Or was it last week? 2 weeks ago. Last week. This is a system that used to be used quite frequently on rear drive vehicles, like the E30 BMW. You actually need both two views. You need the plan view from the top, and you need the rear view as well. And so the plan view, you take these lines joining the mounted points of suspension, and obviously they're going to intersect with the rear axle line. You then look at the rear view, okay? So there's those points here, okay? And these are essentially your instant centres for the wheel. So again, these are part of the suspension. Again, you draw the lines in the For a solid axle, it depends upon the linkage you've got. For this situation with the box linkage, you've got the roll centre in the middle of the